Welcome to this presentation on SKF high temperature bearing technology. We will consider the issues and implications that are presented by this challenging environment and explore how our development of graphite technology can improve bearing performance and compliance. We'll begin by considering some of the issues and implications that are associated with high temperature operation. In hot operating environments, grease dripping and consequent need for frequent relubrication is a common issue. The cost of expensive, high-end, perfluorinated lubricants, along with the associated labour to relubricate, soon adds up. The picture illustrates this well, and lubricant leaking from the bearing positions can in some circumstances contaminate the process and product. Corroded bearings are common in these applications. During baking or cooking, moisture is released and combined with the extreme temperatures, typically around 180 degrees Celsius, this leads to high oxidation levels, accelerating wear and bearing replacement. The corrosion can also cause unhygienic flaking. Entering or working on these assets before they've cooled sufficiently makes maintenance very hazardous, and this can be an issue, but long standstill times while waiting for the asset to cool potentially means less production time, and pressure on production is always key. The grease technology can limit flexibility in operation. Attempting to increase production by elevating the temperature and speed often means that relubrication intervals would need to be halved in order to ensure reliability, but this often negates any increase in production. Some high-temperature processes have varied oven zone temperatures, but use only one type of lubricant throughout. Now, this can be a challenge when the highest zone requirement is at the performance limit of the lubricant that's being used. So our question when studying these applications was, what if we could limit planned downtime and related lubricant cost, remove the need for relubrication with a high degree of temperature flexibility, significantly reduce the risk of lubricant dripping, and improve compliance to food safety, people safety and environmental regulations. Understanding the issues and implications of these applications, SKF has developed specific graphite technology in a high molecular form of carbon. By producing a fully crowned graphite cage in this material to separate the balls, we introduce a self-sacrificing material. Now, this allows the balls to take a continuous flow of graphite powder that also coats the bearing inner and outer race, preventing metal-to-metal contact and allowing operating temperatures up to 350 degrees Celsius without penalty. High-temperature bearings based on graphite lubrication offer a number of benefits. Firstly, there's no need for relubrication. The bearings are lubricated with graphite-based high-temperature lubricants and are lubricated for the life of the bearing. The boundary dimensions are the same as those of standard bearings, which simplifies replacement. Now, these bearings offer operating temperatures up to 350 degrees Celsius, that's 660 degrees Fahrenheit. The internal radial clearance and the lubricant are optimized for operation at high temperatures. The bearings are well protected against contamination. Shields, designation suffix 2Z, protect the bearing. And the entire bearing surface is manganese phosphate coated, which improves running in. For the Y bearing, the grub or set screws in the inner ring make mounting and dismounting very easy. And shields and flingers, designation suffix 2F, protect the bearing against contamination. In summary then, with our experience in these extreme environments, you can run your ovens for longer with significantly less maintenance and associated cost, and with compliance to food safety, people safety and environmental requirements. For further information and to learn more, you can visit the food and beverage area of skf.com. Alternatively, please contact your authorised SKF distributor.